Welcome everyone to the Diodes Incorporated training module entitled High-Side IntelliFETs Product Update. Today we will be covering Introduction to IntelliFETs, a portfolio overview, device basics using the ZX-MS81045 SPQ as an example as how you drive the device, use the diagnostic current sensing, and protection mechanisms. We'll be touching on the evaluation board and benefits. What is an IntelliFET? An IntelliFET or intelligent MOSFET is a smart switching device to connect and disconnect a load. It is always used with a microcontroller and has integrated circuits to guard against electrostatic discharge, overcurrent, overvoltage, overtemperature, and overload conditions. IntelliFETs, just like a discrete MOSFET in any switching operation, have two possible configurations: low-side switching and high-side switching. The difference between high-side switching and low-side switching is the position of the switching device with respect to the load. If the MOSFET is switching ground, it is a low-side configuration, and if you are switching the battery or positive terminal, it is a high-side switching configuration. Low-side switching is easier to implement, but for certain applications, like voltage-sensitive devices, we need high-side switching. For high-side switching, the Diodes IntelliFET devices include a charge pump gate supply to effectively turn the N-channel MOSFET switch on and off. While Diodes Incorporated has low-side IntelliFETs, in this presentation we will be focusing on the new high-side switching IntelliFET portfolio. Diodes IntelliFET portfolio includes both automotive qualified and standard industrial qualified devices in single and dual configurations. All automotive products are AEC Q100 qualified, are PPAP capable, and are manufactured in our IATF 16949 certified facilities. The portfolio currently covers from 34 milliohms to 200 milliohm drivers to handle a wide range of loads. Release of lower RDS-on drivers throughout this year will basically double the number of devices available. Pin-to-pin compatibility with other popular devices will help design engineers meet their dual source supply chain requirements. The ZX-MS81045 SPQ is a single-channel high-side power switch in the SO8 exposed pad package, incorporating protective and diagnostic functions. The device comprises a monolithic N-channel vertical power MOSFET with integrated temperature and current sensors, with a charge pump gate supply, and has a very low quiescent current in the off state. Some specification summaries is that the device will operate from 5 to 28 volts with a maximum supply voltage of 41 volts. The typical on resistance is 45 milliohms, but at hot temperatures the maximum is 90 milliohms. Nominal load current 4 amps. The typical current sense ratio is 1200, and it will go into current limitation at 25 amps. The device is enabled by active high 3.3 volt or 5 volt logic drive to the inputs. This device includes diagnostic current sense output proportional to the load current and a defined diagnostic fault signal in case of overload, over temperature, or short circuit conditions. This is a common high-side switching IntelliFET circuit containing the device itself with the MOSFET and the internal circuits for control and diagnostics, a microcontroller to drive the device and reset when necessary, and the load. During normal operation, the device is turned on with a high VN voltage. Diagnostic enable, or VDN, is also then pulled high. The output MOSFET is turned on to energize the load, and proportional sense current is provided out of the IS pin. Expected sense current, or IS, can be calculated by dividing the load current, IL, by the current sense ratio, or Killis ratio, found in the datasheet. Proportional current sense output should be sampled after the proper settling time, or around 250 microseconds after the on state. IntelliFETs have several current sense outputs to help the design engineer diagnose the health of the driver and the load. In normal operation, the IS pin outputs a small analog sense current proportional to the main output current flowing in the power MOSFET. During overload, current limit operation, over voltage, over temperature, high temperature gradient, or open load in the off state, the IS pin provides a defined current or a fault output greater than the normal sense currents. And during the on-state operation with open load, normal off-state, or off-state with inductive load ringing off current still flowing, the IS current is approximately 0. The loss of ground occurs when we have the load connected, but the device connection from the ground is lost. In this event, the device will turn off. It is recommended to use high ohmic input resistors in the interface pins to ensure that the device is turned off by limiting the current in the paths from the ground pin. In an undervoltage case, the supply voltage is below the minimum operating voltage, or it drops during operation, and the device will turn off, or remain off because the safety functions might not be operational in this condition. During overvoltage transients, including electrostatic discharge, the overvoltage protection is achieved with active protection clamp Zener diodes at the ground and the IS pins. During an overvoltage condition, the excess voltage is applied across the RIS and the RG&D resistors, raising the ground pin potential. Additional high ohmic series resistors may be necessary to avoid high voltage being applied at the IN and the DEN pins driving circuits, and at the IS monitoring circuit in the micro. During an overload condition, the output current is limited by a value depending on the VDS, or voltage between the VS and the out pins. This overcurrent will begin to increase the internal junction temperature. If this keeps going for some time, the temperature protection will be activated. The temperature sensor has two limits: dynamic limit and the absolute limit. First, if the temperature reaches the dynamic value, the device will switch off and on after the temperature drops a certain amount of degrees. When this happens, it is active again. Because the device is cycling only a short time, peak temperature will keep increasing. When the dynamic limiting occurs for long enough, the device will reach the absolute temperature limit, which will then switch off the device and wait until the temperature drops to a specified level before switching on again. This absolute system ensures that the temperature will not keep increasing like in the dynamic limiting section. Finally, if the overload condition is not corrected, the microcontroller we'll need to reset the output. In this graph, we can see the difference between the dynamic temperature cycling and the absolute temperature cycling system. An evaluation board is available for these products and can be populated with any of the High-Side IntelliFET devices. The board allows for easy testing of all load types, including with cable harnesses. The board has multiple passive component options to allow different configurations to be populated. There are many applications for rugged high-side output drivers in both automotive and industrial markets. You can see many are the same across the markets. Anything from blend door actuators to heating and cooling elements in a factory process control unit. Body control modules are switching on interior lighting, actuators or auxiliary power outlets, or industrial computing I/O module might be doing the same thing. Really, any high inrush current load which could benefit from a self-protected driver. As you can gather from this presentation, the IntelliFETs offer many system benefits, such as protection for the driver and the attached load. They provide diagnostic capabilities and easy control. They bring higher system reliability. They're designed for harsh environments. And finally, easy MCU connections. Thank you for watching the High-Side IntelliFET product update. If you need more detailed information and design resources, please dig into our website at diodes.com or contact your regional Diodes FAE for further assistance.